Hi, everyone, and thanks for joining our zED talk. We're excited today to present part 2 of our COBOL mini-series, which will focus on COBOL migration and when to utilize IBM's ABO tool. As it relates to this topic, I'd like to mention that clients are capable of using ABO at no charge until the end of September as part of IBM's response to COVID-19. If that interests you, I'll send more information about that in the follow-up email after the event. Similar to the last session, our presenters are Zvi Weiss and Ed Steele, who are both experts in this area. If you have questions throughout the presentation, please put them in the Q&A panel, and we will address as many of them as we can. And we will get to the ones that we can't address during the presentation afterwards offline. Lastly, after the event ends and you close your WebEx window, a poll should pop up in your browser. It would be really helpful to us if you can take a minute to answer those questions that help us improve in the future. And with that, I'll pass it off to you guys.
Thank you very much, Brian. This is Ed Steele, and I'm joined by my colleague, Zvi Weiss. We are both IBM certified IT specialists. Both of us specialize in System Z and also in the DevOps area. Today, we are on part 2 of our COBOL mini-series, like Brian mentioned. In June, Zvi and I presented COBOL 6.3, some of the new features. And today we're going to talk about migrating to COBOL 6.3 to reduce costs and improve performance. And we'll also be discussing Automatic Binary Optimizer, ABO.
Okay, this is the agenda. And some of this is going to be reviewed because this is our COBOL 6.3 and there are certain commonalities across all of version 6. But we'll be talking about the value, the benefit of staying up with the compilers, some considerations in terms of COBOL 6.3 itself, as well as the Automatic Binary Optimizer. Ed?
So, performance on today's ZOS hardware is delivered with the combination of hardware features and compiler support. So in the past, it was a little different where we tried to optimize the middleware and some of the hardware, and now it's kind of shifting. But performance of COBOL apps does not dramatically, automatically increase the new Z hardware. So to get there, what we need to do is recompile the programs, get it up to, COBOL version 6.3, and then optimize, and then we can refactor. Now, point here that we're talking about is that until now, COBOL never took advantage of the hardware since, I don't know, Z9 or something. It goes back quite a long way. And yet, the hardware had introduced some very nice features, whether you're talking about decimal floating point, whether you're talking about decimal floating point pack conversion, whether you're talking about vector pack decimals, whether you're talking about the decimal floating point. So these are all hardware-based features which can significantly improve execution, and yet COBOL didn't take advantage of that. The compiler, the code that was generated, didn't know anything about any of this hardware. Ed? So if you haven't noticed, Dee and I tag team these screens, these slides, just like we did in the last one in June. And with that, I've got this slide here, and we'll be introducing COBOL version 6.3.
Now, COBOL 6.3, before we get to COBOL mentioning COBOL version 5, COBOL 6.3 is an incremental enhancement over in version 6. Now, as we recently had over here, Enterprise COBOL version 5, and that made a marked change between the versions of COBOL before version 5 and the versions of COBOL with version 5 and going forward. Because from version 5 going forward, we started to have a runtime that took advantage of the hardware. We changed the way that the debug form was created. We now required a PDSC, and we required things that were different from the original code from COBOL 4 and earlier, but at the same time, we maintain the source compatibility so that programs that compiled under COBOL 4 will compile under COBOL 5 and 6, okay? And we can call COBOL version 4, COBOL version 3 programs from COBOL 6, okay? We have good interoperability, and we can also take advantage of the DevOps. I will point out that we do not go all the way back to the remote prehistoric past, and so we do not interact COBOL version 6, COBOL version 5, COBOL version 6 does not interact with the old OSVS COBOL. You don't have to answer this, but people should think, when was the last time anybody had to compile something in OSVS COBOL, and why? Ed?
So, talking about COBOL migration here, in this chart here on the left, you can see the first column is the compiler. The next column is what happens in the front end. And then the next column here is the back end that handles the optimization and the code generation. So the front end parses the language, and then the back end does the optimization and generates code. So we can see here where a red line is that a migration is necessary because of infrastructure changes, right? So to go to OSVS COBOL to VS COBOL 2, there needed to be a migration. And many of you maybe have already done that and experienced that. And then until the next line, the next red line, no migration was required. You just had to recompile to get there, right? So, and now going from 4 to 5 to 6, now a migration is required. And as V said, COBOL 5 and 6 does not interoperate with OSVS COBOL.
So let me just mention, to give you an idea of what it was talking about, if somebody had VS COBOL 2, which was just past the red line, and changed to COBOL 4.2, in many cases, the developers didn't even know, because it was so seamless. The changing the libraries over, yeah, they had some new features, they had some new capabilities, but functionally there was no difference. But now we have a version of COBOL that uses an entirely different parsing mechanism, even though it's syntactically compatible, and it creates different runtime code because it leverages the hardware. So as a result, you're now using more memory during when you're compiling. You're having a lot more CPU while you're compiling. You have more work data sets. You're taking advantage of the above the 2 gigabyte storage level. All of this is changing the way, but even though the compile takes longer, you're now producing code that's much more optimized. However, there is a catch. In some cases, notice I say some cases, the way that the runtime, the program that's compiled will behave will be different if we're talking about processing invalid data. If you're processing valid data, your programs will run exactly the same. It's if you're processing invalid data that you're going to have a problem. In addition, as I mentioned earlier, you now need to have the PDSE for the program object that's created. If you try to do a link edit into a PDS, you'll get an error message. And you cannot interoperate with OSVS COBOL or with VS COBOL to NoRes, which was very similar to OSVS COBOL, because of the significant difference between both the syntactical portion, the front end, and the rear end. And so this is something to keep in mind. However, VS COBOL 4.2 can still interoperate with OSVS COBOL. So if somebody is stuck, they have an OSVS COBOL program that they cannot get rid of, if you retain the COBOL 4.2 program, So COBOL 6 can call the COBOL 4.2. COBOL 4.2 can call the OSVS. Ed?
So what's different about COBOL 6? This slide's a little bit complicated and gets down in the weeds a little bit, but there are some bind time differences that you need to be aware of, such as the old bootstrap routine named there that can cause problems for VS COBOL 2 programs that are mixed with COBOL 6. So be aware of the link edit bind time correction, and you will have to update VS COBOL 2 load libraries that are called dynamically if they contain programs that are not being recompiled. So, like the bullet says here, the AMODE 24 COBOL 6 is very similar to COBOL version 4 with a few of the bind time differences. RMODE 24 has to be specified if a program object contains Enterprise COBOL program compiled with RMODE 24 or no reentry. And a VS COBOL 2 program that's compiled with no rent or no reentry, an assembler program containing a CSEC with RMODE 24, or like a pre-version 5 COBOL program that runs with AMODE 24 and statically calls a program that is COBOL 5 or greater. V, you have anything to add on that?
No, it's basically, but you'll notice, just go back to that file for a minute. You'll notice that in that case, the only thing that is necessary is simply to specify the appropriate binder action. I mean, we're not talking about, impossibly difficult things to do. This is something that your systems programmers should be able to take care of without any issue. Okay.
Right, and developers probably won't see it.
Right. Now, so what happens is when you're moving from COBOL 4 to COBOL 6, first of all, don't panic. Okay, the support time for the COBOL 4 compiler has been extended, and you do not have to run and say, "Oh, I got to recompile everything." And in many cases, I would say, don't recompile everything, because COBOL 6 can call COBOL 4 without any problem. So what you want to do is you want to plan, what am I going to change? At the same time, some things you will have to do is, if you're going to recompile, you're going to have to use PDSEs. Now, you may already be using PDSEs, so that's a non-issue. But if you're not, this is a time to really, crack the whip and say, okay, I'm not going to use PDSEs. If I have the OSVS COBOL programs, which I really shouldn't have, because we're talking about a compiler that I think is older than many people in the audience. OSVS COBOL goes back to the early 70s. Okay, it was VS COBOL 2 was already by the late 70s. So we're talking about a compiler that is, I think, almost 50 years old. So I would hope that you don't have, but if you have them, now's the time to migrate them. What you do is you migrate it to VS COBOL 2 without the NORAS option, that's the VS COBOL 2 or the COBOL 4.2. You now migrate it so that it would then be able to be migrated to COBOL 6. The main point is, if your program process is expecting to process invalid data, make sure you process invalid data correctly. Although that statement probably sounds a little bit contradictory. But the idea is, if you encounter invalid data, you want to know what you're going to do with it. And in many cases, people didn't know what they're going to do with it. They sort of relied on default behavior, and the default behavior now becomes very weird with COBOL 6. So that's why it says fix invalid program and data issues. And that's what you have to test for. But the good part is, after doing all this work, you never have to go again to migrate. That is, once you've made the jump to COBOL 5, COBOL 6, COBOL 6.x, COBOL 7, you're not going to have to go through this kind of effort again. This is a one-time effort, and in my opinion, it's worthwhile doing simply because you'll have a cleaner program. Ed?
Okay, so like Z was talking about invalid data in COBOL 6. You know, they say here about 25% of customers migrating encounter migration problems because the COBOL programs processed invalid data at runtime. So we see people that say, my program worked before, what changed, right? And why doesn't the compiler give an error diagnostic for invalid data? Well, programming best practice is to always validate the data types, and to initialize your data values, before it's used. And it's always up to the programmer to ensure table arrays and parameters are coded and used correctly. So in COBOL 6, these different instructions can process invalid data differently. And it may not be a problem, but you need to test for that. And why doesn't the compiler give errors for invalid data? Well, it will, and we'll show you some. But in general, data values at runtime or data that you're passing between programs is really not in the area of the compiler. That's where programmers need to focus and use best practices. But we can help you get there.
Yeah, so I tell people very simply, our compilers are not mind readers, nor do they have the gift of prophecy. So at the time of compilation, it's not encountering any invalid data because the program's not running at all. So what's the compiler supposed to flag? Nothing. Now, why doesn't they enforce rules? Okay, well, first of all, because it's kind of difficult to test for invalid data. If people remember that poem, How Do I Love Thee? Let Me Count the Ways. Well, it's how do I have invalid data? Let me count the ways. There's a whole lot of them, and it's impossible to test for. I mean, I'm sure that anybody in the audience can think of some sort of invalid data that we wouldn't think about. In addition to which, we just didn't enforce standards for certain things. We sort of let things go by because we didn't know that people would do what I would call bad things. And I don't know if there's a nicer term to use, but so therefore now we're having a compiler that's more sophisticated. We're starting to enforce the rules a little more strictly, and these kinds of things are starting to show up. And we provide the ability to make sure that you don't get into trouble. We have the numeric class test. Okay, if you're not sure if your data is valid, just do it in a numeric test. Not so difficult. If you're afraid you're going to bounce it, explode from a table, use SS range, right? It'll tell you right away, and then presumably you'll set up your program so you won't, exceed the table. So we give you the capabilities to address the issues that could create problems. Of course, we cannot twist anybody's arm. If somebody does not want to use numeric, if somebody does not want to use SS range, if somebody does, that's their choice. But then if they get funky results, that's also their choice. What we're trying to tell people is we're giving you a protocol to avoid funky results. Ed?
So how did we get there? The migration issues caused by invalid data or parameter passing, like we've been talking about, are things like invalid data in a numeric usage display, or users of trunk opt or trunk standard with overpopulated binary data items. So you're loading a field with more digits than it's defined for, right? Parameter and argument size mismatch. Maybe you got a COBOL program and it's passing to a subroutine or a COM area and it doesn't match. Data items that are used before they're assigned a value. So back to the init clause. It is a best practice, so use it. Says here all other known issues with invalid data causing these behaviors has been resolved in PTF. So we recommend that you apply all the PTFs and frequently update using the PTFs that come out new and keep things fresh. Only installing ZOS recommended service upgrades is also a good way to go, right? So again, another best practice. But it's up to the customer to make the final decisions on what they want to maintain and what they want to install. So you got to put your heads together.
Okay, before I get to the actual example, I just want to elaborate on a point that Ed just mentioned, and that is if you apply the PTS, you will find that you're going to these levels with basically effortlessly. If, for example, a person at COBOL 6.1 and applied the PTS ended up with COBOL 6.2. When they applied the PTS, they ended up with COBOL 6.3. They didn't have to specially install anything. So this is simply, emphasize the point that Ed made, that when you have the compiler, making sure that the service on it is current is really a good thing. Now, here's a wonderful example of how invalid data, where you don't apply a numeric class test, can really mess you up. Okay, you'll notice, and it's all valid. Everything is valid. You have an alphanumeric item that has 0, 0, blank 0, which in hex is F0, F0, 40, F0. You now have a redefines that says it's numeric. That's also, you're allowed to define the do redefine. You now say if F2 equals 0. Now this is going to, how is the compiler going to evaluate this comparison? Well, you can flip a coin, because there are two ways to do it. Remember, A2 is defined as numeric. So the compiler can either do a compare pact as a numeric compare, or it can do a compare logical. And this will depend on how A2 is used in the rest of the program. The compiler's algorithm for determining the compare looks at the usage of this numeric item and based on it says, okay, I'm going to do one kind of compare or another. So let's see what happens. If I do a character compare, 0, 0, blank 0 is not numeric, and it will say it is not. It's not numeric. It's not equal to 0. Okay, 0 doing a compare logical CLC on 0, 0, blank 0 will definitely not be 0. And so you will take the branch that says else display not 0. But if you do a compare pact, what does pact do? Pact strips off all the zones except for the last one, and so 0, 0, blank 0 becomes pact 0, 0, 0, 0, F. That's a numeric 0, a zone decimal pact numeric 0. So then we'll say it is 0. Well, how do I know what it's going to do? Well, I don't know what it's going to do. That's why doing this kind of invalid data gives a very funky result. Okay, and that's why it says the character compare would not be equal, the numeric compare would be equal, because they operate differently. And in this case, what the user should have done is said, if A2 is numeric, then if A2 equals 0, whatever. Ed?
So how can we identify that invalid data that Zvi's talking about? We could add the if numeric check, just as he said earlier. In the past, we also had a thing called zone check, and now we can compile with a new parameter called numcheck when we do the compile and the test. So use this compiler option, and you could get a message or append when the data is invalid. So you see there a little bit of history. The zone check is still tolerated as numcheck zone, but we are encouraging the use of the new parameter numcheck. And it can also check packed decimal and or binary data.
Now, before I talk about this, how to correct, keep in mind that if the user would put in their own numeric test strategically, it will probably run a lot more efficiently than putting in the numcheck zone which is going to every place, automatically do a numeric class test. So again, this is, you can clean it up yourself, or you can let us try to clean it up for you. But it's usually better if you clean it up yourself. How to correct using numcheck zone or zone check will correct this. Okay. In addition to which, you can, when you're using the moves, use the correct move to use. Right? If you're doing a move corresponding, or as opposed to just a group move. The point is, if you can't fix it, then you can put in zone data. But from my perspective, if you can't fix it, it usually means that there's something, architecturally wrong with the program, because normally you should be able to be able to detect your numeric classes correctly and be able to avoid this kind of a problem. Ed?
So this table here really shows what options that you should use. And on the left, you see in version 4, they used the numproc the way the examples show here, yes or no, on the, or is the data valid, and what proc to use. And then over on the right, it shows how you should use the new parameters in version 6, right? So the zone data option tells the compiler whether the data in the usage display and the packed decimal data items is valid. And if it's not, then what behavior of the compiler should be? What should it do? So again, this chart shows you which new compiler option to use in COBOL 6, and it compares it to the options that were available in version 4.
Right. Keeping in mind, Ed, go back just for a minute, just to point something out. Keep to the previous file for just a moment. Keeping in mind that for numproc, the migration sub-option no longer is there. Okay, numproc MIG was added from going from an earlier version of COBOL, and now they dropped that sub-option, and you're left just with preferred or no preferred, PFD or no PFD. And in most cases, if the data is valid, we prefer to have ideally PFD, because that will be the most efficient. But at the very least, if you have no PFD and PFD, that's also good. It's where your data is messed up, shall I say, you're not sure what you're going to get. So there you're going to use no preferred plus a MIG sub-option for zone data. Okay, could you go to the next foil? Now, this is the example I mentioned earlier. When you compile with that zone data, that sub-option, so what happens here is you now get a message. That is, I have the same as I had before, but now it tells me that this value of XF0F040F0, which was 00 blank 0, is failed the numeric class test by the numcheck zone that had been specified as part of the compiler. So the compiler generated an if numeric test for you. But this way you have this warning, so now you know either fix it or put in an explicit class test. Do something. Don't just, and so you can now take care of it rather than having something happen during runtime. Because I tell people, the only bug that's worse than the one that causes an add-end is the bug that doesn't cause an add-end.
Right. So data items that are used before giving a value, right? The initialize. So you take a look at this working storage structure, right? X, Y, Z in here. And then the code display the X and do a compute based on an if statement. But these are not initialized, so we really don't know what we have at runtime until we've either used them or read a file, and we don't know. So, and it depends on what our runtime options are and how the memory is laid out, where the program is loaded into storage. So uninitialized memory isn't guaranteed to have any specific value. We just simply don't know. COBOL version 6 cannot guarantee the value has the same memory as it did in COBOL version 4. So once again, we need to adhere to some best practices.
So the easiest way to do this is to use an option called init check. Init check will tell you, hey, you didn't initialize this. And this will show, this is a very useful compiler option because it shows up during compile time. In other words, the compiler as it's compiling, the compiler can detect that you are doing an arithmetic operation on a variable that has apparently not been initialized. So this does not consume execution time, but it gives you the warning that, hey, you didn't set this value here, and you might have a very unpleasant surprise. You know, and just to build on what Ed said, in COBOL version 4.2, I believe that something was not initialized. It was either 0 or low values, and you can count on that. Well, in COBOL version 6, you can't count on anything. It could be 0, it could be low values, it could be, you know, ABC, it could be anything. It could be just, you know, rubbish. And that's really not a good situation. So therefore, use a value clause, move something into it, do initialize, do something. Don't ignore it. Because if you ignore it, bad things happen to good people. Ed?
Okay, so like Z said, you can turn on the compile option, right? And you get the warnings. And this is what you would see down below here. The data item X may be used at this statement before it is set, right? So it's telling you, basically, you better initialize this stuff because you don't know what you're going to get. So you can see in this code that working storage values had not been initialized, so you may get unexpected results. But the good news is we give you a warning.
Now, this is a protocol to use when you're actually going to see if your programs are behaving themselves. Okay? The first time when you're going to go to COBOL 6, so this is like, you know, bake twice and taste once. So you're going to, the first time you're going to compile with options that clearly you should normally never use in production because they're going to affect the speed of execution. You're going to use SSRange to see are you exceeding your table bounds. You're going to use numcheck to see if you, like we saw, using numeric is data that is not properly numeric. Parm check to see if, which we'll get to a little bit perhaps if there's time, about the length of respective parameter lists. Init check to see are you initializing your stuff. And obdo, which means don't bother to optimize right now because we're not running in production, and so this makes it easier to debug. One of the features of the optimizing compilers that it rearranges code. Now, rearranged code might run much more efficiently, but usually rearranged code is harder to debug because it's not quite where you expect things to be. So in this case, we're not going to optimize, and now we're going to look and see what messages came up. We're going to see what kind of error messages came up. Did I have SSRange? One of the new features about SSRange is that it used to be that you see the table, you get an event. Now there's an option for SSRange to just get a message. So if I see tables in different places, I can get different messages. So I can look at these error messages, I can look at the logs, I can see what's happening, and I can say, oh, this is what I have to correct. Once I correct everything, then I recompile for production. Now I'm going to take out the options that affect efficiency. So there'll be no SSRange, which is legitimate because presumably I've corrected all the instances where there had been table violations. I can do no numcheck because presumably I've now put in the appropriate class tests where necessary. And I can take out arm check because I've made sure that my parameter lists are now equivalent. They're the same length for both the called and calling programs. And I can do op2, which is the highest range of optimization. So there, and notice I can leave in a init check because the init check does not affect the execution. It's at the compiler time. So now, if you see what I have a two-compiler process for migration. I compile once with the options that let me see how I process or do I process invalid data. I fix everything, and then I recompile for production. The only time I know cases where people leave in SS range, even though it affects execution, simply because, and I've never understood why, but they have instances where they cannot fix table violations, that they cannot eliminate them. I don't know why they cannot eliminate them. I've never understood, but they said they couldn't. And rather than have something blow up with a table violation where you don't know what went wrong, because that's what happens with a real table violation, that you see the table and then much later on data is corrupted, they will leave in SS range even though they don't affect execution efficiency. However, assuming you can correct everything, you can compile for efficiency by saying, I don't need SS range, I don't need nut check, I don't need palm check. I can leave it in check because that's purely compile time, and I can go for the highest level of optimization. Ed?
Okay, so this slide that V's on, I mean, I see this as really in the shift left paradigm where this is probably the role of a developer, right? To do these options and make the first initial couple compiles to see how things are working. And then also to help the developer with writing better code and seeking best practices, we recommend using the rules compiler option, which gives the developers information about their program. How is it written well? Is it easy to read and doesn't throw off errors that you don't expect? So things like no end period would flag a conditional statement that doesn't have a period. No even path.
It does have a period.
Flag some. Sorry?
I'm saying it flags the statements that have a period.
Yeah, with a period, yes. Yeah. And then these other options like no slack bytes, or synchronizing your data items, or the no omit ODO min, which is don't omit the occurs depending on minimum, right? You shouldn't say occurs depending on 100. You should say occurs depending on 1 to 100, right? So don't omit the minimum. Anyway, these are the things that can help you write good solid code. We recommend always using diag trunc to find hidden loss of data where statements might truncate numeric items. And then you could also use IBM Developer for Z Systems to run the scanning feature, the scanning COBOL programs compatibility feature, to check for parameter mismatches in call statements to make sure you're not, overloading a working storage area.
Okay, I want to mention 2 points relating to what we just saw about the rules. First of all, it is possible for the user to go in, and normally rules just give a warning message. You can actually go in and change something to an error message if you want. I don't say to do it. Some cases I would consider it. No end period is probably one of the most important rules that exists. Because since normally COBOL programs are written without any periods in the procedure division, every once in a while somebody has an old program and they leave a period in and they don't realize it. And having a period in the middle of a conditional is a really bad thing. And it's really hard to track down. Because what will happen is that the program will seem to operate properly if it's not taking the branch where the period is. So having no end period is probably one of the most important rules that you can consider implementing. Okay, the next now, getting into what we're talking about, because COBOL 6 is sensitive to the hardware, make sure you have the right ART setting. Okay, because if you have the wrong ART setting, like if you're having an ART setting for a Z14 and you're running this on a Z11 or Z10, it is going to absent because the instruction will not be comprehended at all. I mentioned earlier that nonproc MIG was removed, and therefore you saw we had a table about the using nonproc no PSD or zone data MIG. Because of that, there's some other options to check through, but normally the other options that you use in COBOL 4, you can use in COBOL 6 without any problem. Ed?
So we can help you get there. Then you can register for a free COBOL migration and performance webinars. As you see here, we can help you plan the migration to COBOL 6. We can give you recommendations and best practices. And the performance tuning webinar, you should leverage that just, to make sure you understand what you're gaining, get advanced optimization, and then you can follow up on the migration workshop, and you see the link here at the bottom. But it's always good to measure where you're at now, and then you can do apples to apples comparison and figure out what kind of gains that you received. And we can help you plan all that.
Now, suppose you can, we also give you the guidance, the migration assistant. The migration assistant actually walks you through, gives you a checklist for everything that we've described so far. So you have a checklist of what you're doing step by step and actually logging it so you're not going blind. And it's a no-fee feature, and it can certainly be very helpful. Ed?
So COBOL 6 and ABO executes most efficiently on a Z14 or Z15 hardware. On the Z14, you can take advantage of the vector pack decimal facility, where all the computations are done in hardware registers instead of memory. On the Z15, you can leverage the vector pack decimal enhancement facility. So it does faster decimal conversions and arithmetic operations. It accelerates the interlanguage applications and enhanced digital move performance. And the nice feature of this is there's no source code changes required at all. You simply recompile to the new arch level. And one word of advice here is you don't want to forget about your disaster recovery site. So a best practice is to have the same arch level on the production machine and the disaster recovery machine, so you don't have to keep, separate levels and separate libraries, things like that.
So now we'll go through this very quickly because we still have to get to ABO. But just to review, because we spoke about this last month, COBOL 6.3 now has AMO 64 support. COBOL 6.3 now has dynamic length elementary items. Okay, so this is in addition to the current depending on. And you now have additional intrinsic functions that let you do some very nice things. And it supports UTF-8 data, which can be very, very important for the international processing.
And we did cover a lot of that in our previous zED talk in June. So if you want to know more, you could refer back to that. So we have got over 900 customers that have already migrated or are currently migrating to COBOL version 6 or version 5. And performance improvements reported by the customers listed here is 10 to 20%. And we've seen, I think, some of the numbers show 22, 23%, but generally speaking, we're seeing 10 to 20% improvements.
Now, this is the automatic binary optimizer. This is for cases where you cannot migrate or your migration is going to be delayed. And so we're giving you an option that helps you get your code taking some advantage of the hardware. Now, I'm not saying total advantage that you have the compiler, but significant advantage. Ed?
So what is what is Automatic Binary Optimizer? We call it ABO. ABO really is a complement to COBOL version 6. So as V said, you can exploit the hardware features of a new System Z machine without migrating to COBOL 6. ABO optimizes the load modules compiled with VS COBOL 2 up to COBOL 4. ABO targets the new system machines as listed here on the chart, and it exploits the hardware features to improve COBOL application performance. You can significantly reduce the migration to COBOL version 6.3 while realizing the performance benefits of the new machines. There's no need to fix problems in existing source due to poor programming practices. You can simply optimize the performance with ABO and it'll continue running as it always did. So ABO can complement COBOL version 6. You could implement ABO immediately and gain some performance in your existing modules, while at the same time moving forward with the migration to COBOL 6 in parallel.
So this is what actually happens. When you're using ABO, it's working at the program load module level. It's not working. That's why you don't need source. In fact, if you don't have source, ABO is probably your only option instead of trying to recompile. So it takes it, it unbinds it, it now looks at all the instructions, it creates a model, using that model, it figures out what instructions can be substituted for what, it then rebinds it, and it creates a new load module. So what happens is that it's not affecting the logic because the source is not being rearranged at all. You're not introducing any new intrinsic functions. All you're doing is that some of the old instructions that were storage instructions now become register instructions. So ABO, it will improve the object code, but it does not give you the new intrinsic functions. It does not give you all the new features we spoke about last month. That you don't get with ABO. What it will do is it will take your existing code and make that code run better. Ed?
Okay, so as Z's talking about, how does it work, right? So we use the load module or the binary as input, and ABO does not change any of the logic. It optimizes the original binary. So you can expect that you'll receive the exact same behavior, right? The options are unchanged. No compile options, performance or otherwise, are being changed. It's staying the same. And then full interoperability. The optimized programs run faster and would behave the same as the original program. You're taking advantage of the hardware and the ability of ABO to get you the performance improvements. Well, before I move on, I want to point out here, V, that it does require some testing to make sure that you're not going wrong somewhere, right? So you want to get the optimization done and then run some tests and make sure you're getting the same results.
Right. So what's happening here is normally what happens when I'm compiling. When I'm compiling, I have to unit test and I have to system test. I do a whole bunch of things. When I'm doing ABO, basically all I have to do is take the optimized module and test it once because nothing else has changed. So you saw before that we spoke about migrating. You had to compile twice, and you had to test in between, and you had to change the compile options. You're not doing any of that. Now all you're doing is you're taking a load module, you're transforming it, you're doing simple tests, and then you're good to go. Ed?
So this chart compares performance of ABO 2.1 to COBOL 4.2 on a System Z15, right? And it also shows performance of ABO 2.1 and compares it to ABO 1.3 on the same type of machine as Z15. So you can see here it fully exploits the Z15 hardware, taking advantage of the vector pack decimal enhancement facility. And here we've got a CPU usage of up to 22% reduced for the COBOL applications. And you can see here up to 53% reduction in CPU and 30% reduction in memory usage over the older version of ABO. So pretty significant hit here.
Now, what's nice about ABO is that it tells you exactly what it did. So over here you can see that originally you were doing, to do this instruction, which was a simple add instruction, you did a move character, you had to do an add pack, which is a storage instruction, you had to do that, okay? All that stuff had to be done. What happens now when the code is transformed? It's taking advantage of the hardware architecture, and so now you have vector-backed instructions. There's no LE overhead. Everything is a register instruction. Clearly, you can see now why this runs faster. Ed?
Okay, so here you can easily see how ABO has optimized the code in the listing. So this is what you'd be looking at after you've ran ABO, right? So the input source code starts in column 1. The optimized code starts in column 5. And the optimized instructions annotated with the source code offset. So then you can easily compare and you can track the changes. It's very nice.
Okay, so now what am I going to use ABO for? Because ABO is not an end-all be-all. ABO improves the COBOL code. But if I have a COBOL program that states not doing very much, it's calling kicks, or it's doing DB2. So then it's not doing anything. Kicks is doing something. DB2 is doing something. If it's doing I/O, it's doing a lot of reads. So ABO is not going to be a big help for you there, simply because the COBOL itself is not doing much. If I have a COBOL program that basically simply calls kicks and has kicks run and then it comes back and there's maybe 25 lines of COBOL code, I'm not going to get very much benefit because ABO is not optimizing kicks. If I'm doing a lot of DB2 processing, it's not optimizing DB2. So we have to know where we will get the benefit of ABO, which means that the execution is primarily inside of COBOL. In addition, we want to look at COBOL statements that are doing work, whether it's compute, whether it's an if, but COBOL statements, if, move, add, all these are doing work. We actually have a protocol that involves using either the application performance analyzer, or we can use also ZBNA, the Z binary network analyzer, where we analyze the actual execution of programs. These will tell you the heavy hitters. These will tell you the COBOL programs where the programs themselves are eating up a lot of resources and are therefore suitable candidates for use with ABO. Ed?
So, like Zvi's talking about, how do we know? How do we get the benefits? Where do we start, right? So we need to identify the modules that are the heavy hitters. So this chart shows you where to start with ABO or with a migration to COBOL version 6. So number 1, you could start by identifying peak CPU usage times. Look at the time of day or the days of the month when the CPU usage is the highest. Next, you could identify top jobs. And here it states you can use SMF type 30 records and look for jobs that use the most CPU. And we have the ZBNA tool that you can also use to help visualize your CPU utilization. Number 3, you can identify programs that use the most CPU You can use ZBNA and help identify CPU times and even look at your EXCP counts and see where all your IO's going. You could identify top modules, use Performance Analyzer like Z talked about, Application Performance Analyzer, to discover what candidates might be good for ABO or which ones might be better off using a migration. And then you can use ABO scan mode to identify COBOL CSECs that might be potentially optimized.
Okay, wait,
Oops, did I skip one?
Yeah, go back.
There we go.
So anyway, we do have a deployment project office, which helps people use it. The DPO programs provide no charge 40 hours of guidance. They will give you a deep dive here. Very, very worthwhile. DPO it comes up is a functionality that customers should, in my opinion, take advantage of. It's provided by IDZ. It's provided over here by ABO. It is definitely will provide effective guidance in how to use it, when to use it, and the best practices. And we are just about at the end here.
Yeah, so COBOL and ABO, we announced into service for COBOL version 4.2 and 5.2, and it's only into service for the compilers. We do still support the runtimes in LE. And then we're also on the new version of ABO. So effective in April 30th this year, we are now on the new version 1.3.
And now, actually, yes. And now we have, then at 1.3 went up to 2.1. You can see that what we mentioned earlier, ABO works with COBOL 6. Ideally, you should try to migrate to COBOL 6, where you cannot do so because you're not a PDFs yet, or you don't have the source code, or you don't have the time. That's where you can use ABO. Okay?
And the best practices for migrating to COBOL version 6, you can use them together, and you can make changes to your COBOL program, and you can use COBOL version 6 as your production compiler. And then for programs that are not changed often, you could optimize them with ABO and get the performance enhancements that you're looking for while you're taking your time with your migration to version 6 COBOL. Oops.
Okay, this is because we're running, toward the end. I'm just going to mention this shows you many other DevOps tools which you can use in conjunction with your migration to COBOL 6, whether we're talking about IDZ Enterprise Edition, Fault Analyzer, Application Performance Analyzer, which you mentioned earlier to help identify heavy hitters. These are all the instances of tools that can help you. Ed?
And we offer trials, no charge evaluation for a 90-day license. And we can help you get there, right? With the same functions as a GA product, ships with the latest PTFs. And then we can also have an offering in the cloud. And this is all available on ShopZ. And as Brian mentioned in the beginning, we have an offering for COVID. So take advantage of those things. Okay.
I'm not going to go through this because we're really running out. I'm just really going to talk about how IBM Enterprise COBOL gives you all these features, takes advantage of the hardware, gives you modern, gives you modern capabilities within your COBOL programming, and is an accompaniment. Complement. Ed?
And here's some additional resources, and you'll get the slide deck here so you can find out where to go to get additional information. And if any of you would like to follow up and get a particular session for your own company, your own IT group, you can contact Brian or Zvi or myself, and we can help you get there.
Thank you very much.
Okay,
Brian?
great.
Brian, I think we'll turn it over to you. We're out of time.
Okay, great. Thank you, guys. thanks again for presenting. Great job as always. For the sake of time, I've recorded the questions and we'll take those offline after the call, just because we're a little bit past our time limit here. So for those of you that do have questions, I'll reach out to you as soon as we can afterwards. Additionally, I'll be sending out the recording of today's session along with the presentation deck in the next day or so. Also, as I mentioned at the beginning, please fill out the survey that you'll see after you close out your WebEx. So thanks again for tuning in, and we look forward to our next zED talk in August, which will be changing topics to discuss DB2 REST API services and how it relates to z/OS Connect. So thank you again, and I hope to see you there.
Thank you all.